Okay. In this session, I'm going to explain total quality management tools. So, third unit of total quality management. Already we have discussed about unit 1 and 2. In that unit 1, we have discussed about basic approaches of total quality management. And then second unit, we have discussed about some of the principles of total quality management. Okay. Today, we are going to discuss about unit 3, total quality management tools. In the third unit, we are going to discuss about some of the topics. Uh, Basic 7 tools of quality, new 7 management tools, Six Sigma, concepts and process, quality cost, re-engineering process, improvement strategies, Taguchi principles, quality loss functions, role of IT in total quality management. So these are the topics we are going to discuss in the third unit. In that first I want to discuss about basic 7 tools of quality. Okay, these are the basic 7 tools of total quality management. Okay, first one flow chart, second one check sheet, third one histogram, fourth one Pareto diagram, fifth one cause and effect diagram, sixth one scatter diagram, seventh one control chart. In that flow chart is nothing but already know is nothing but a sequence of process. That is a step-by-step process will be represented as some standard symbols that's called as a flow chart. And then check sheet is nothing but a systematic data gathering by tabulating the frequency of occurrence. Okay. And then third one, histogram is nothing but a graphical representation. So graphically displaying the frequency distribution of these numerical data. Okay. So and then Pareto diagram is nothing but identifying the vital few causes that account for dominant share of quality loss. Okay. And then fifth one, cause and effect diagram is nothing but identifying and analyzing the potential cause of a given problem. And then sixth one, scatter diagram is nothing but show the relationship between the two variables. That's scatter diagram. That means two variables. It shows the relationship between two variables. Control chart is nothing but identifying the process variations and signaling corrective actions to be taken. That is, these are the 7 basic tools of total quality management. So based on that, we can analyze the quality of the product. Okay. So first one, flow chart. So flow chart is a graphical tool for identifying process. Something but a step-by-step process. Constructing flow chart leads to a better understanding of process. The flowchart is a simple mapping tool that shows a sequence of actions within a process in a form that is easy to read and communicate. So we can easily, if you see the flowchart, we can easily understand the total process of the product. Okay, that's a flowchart. Here there is some basic symbols. So this symbol represent operations. It means it performs some actions. Okay, and then this symbol represents the storage. It is a storage of finished good or raw material waiting for actions. Okay, so and then this symbol represents the delay or temporary storage. It means so process can stop due to some reasons or waiting for next event. Okay, so and then another next symbol is a transport symbol. So that means a movement from one place to another place. Okay, and then this symbol represents the inspection, checking the quality and quantity of the product. Okay, this symbol represents the operations come transport. Doing the work by moving. Okay, so and then this symbol represents the inspection come operation. That means automatic process that describe the automatic process of the symbol. Okay, so these are some of the some standard symbols. So these symbols already we know this is start and end symbol, and then this is an activity. So this timer symbol represents the decision point. That means either yes or no. We have to take decision either yes or no based on the conditions. Okay, so this is a point at which the flowchart connects with another process. So this is an symbol. This symbol is to represent the an off page connections. Okay, so this all records are, this symbol is represent all records are identified. Based on that, we can draw the flowchart of the product. So this is example flowchart of the product. Here first is initially the order will be received from the customer, and then after that has purchase order for payment been received. Either check the conditions, order received, the payment is received or not. If it is received means no means wait until the purchase order received. Otherwise yes means do the next process, take decision of next process. Can order quantity be meet from stock. the stock is available or not. If the stock is available means it do the next process. If it's not available, you have to wait. So produce according to the specified demand. Based on the demand, you have to produce. Okay. So another one, if condition is true. That is a yes means stock is available means check due date against lead time and set shipment date. Okay, here the product is available means first check the due date and then expiry date, like that you have to check, and then process the next stage, and then package the product, and then ship the product, and the product received by customer. This is a process of flowchart from customer order any product and received from the particular product. Okay, so there is a flow chart. Based on that, we can draw the we can easily understand the process of the order and then placed and then delivered to the particular customers. Okay, so this is flow chart. Another one is check sheet. Check sheet is something but it's a tally sheet. Okay, check sheet also known as a tally sheet is a form for systematic data gathering and registering to get a clear view of the facts. It is used to keep track of how often something occurs. Okay, so this is a check sheets. In the check sheets we have uh, it's another form. Check sheets are something which to something but is to store the records. Okay, so these are some of the checklists. Okay, so a checklist may be constructed using the following steps. First step is formulate the objective for collecting data. First you have to collect objective for collecting the data. Second one, decide which data is necessary. You have to decide which one is necessary, and then the next one, determine who and how data will be analyzed, and then fourth one, draw a format to record data collected and that record data. So problem wise putting tally lines, and then fifth one, start counting by darling the list like 1 2 3 4 and then 5, like that. Okay, so this represents the 1, this represents the 2, the number of lines. Okay, and then here we have 4 lines and the cross 1 line where represent the 5 occurrence will be in the particular event. Okay, and the 6th one, mark on the list total number of facts which are noticed. Like we have example, this is the check sheet diagram. Here problems and then occurrence frequency, how occurrences. So delivery is here 5 plus 2 7. Okay, here packaging 2 only to frequency of 2. Okay, so quality performance here reaches the 5 check sheets, and here reaches the 5 check sheets, and then here 1 totally 11 frequency, and then personal here we have 5 plus 5 10, and then invoicing 5 plus 5 plus 5 plus 3. Okay, so total 15 plus 3 18. Okay, this is check sheets. Okay, so another one, histogram. So histogram is nothing but a is a bar chart or diagram showing the distribution of variable quantities or characteristics. It is a graphical display of frequency distribution of the numerical data. The data are displayed as a series of rectangles of equal width and varying heights. So based on the heights we can represent. Okay, this is a histogram. So this based on the values. So equal width and then height will be varying. So based on that we can represent the histogram. Okay, how the product here it quality is achieved minimum, here quality will be achieved maximum, like that we can mention the diagram. This is bell shape, this is doubly peaked, and then this is plastio, and then this is compo, and then this is isolated peak, and then this is HDP peak, and then skewed, and then truncated. So these are all the histogram diagram examples. Another one is Pareto diagram. So Pareto diagram is nothing but is used for separating the vital few causes that accounts for dominant share of quality lost. So it's also known as a 80 is 20% rule. That means Pareto analysis is called as a 80-20 rule, and as a ABC analysis. It means that 20% of problems account for 80% of the effects. Okay, 20% problem B is a major problem in the total product. Okay, that's a 20 percent problems account for 80% efforts. Okay, so this is Pareto diagram. So this is a diagram it represents the Pareto principles. Here we have troubles, and then here a number of reports. So based on the number of reports, the troubles will be in, like that we can represent the diagram. It's a Pareto diagram. So minimum amount of problems. So can small amount of problem. That's 20% of the problem will based on the will lead to the big problem, big effects. So that's a that will be represented as a Pareto diagram. So another one, cause and effect diagram. Cause and effect diagram is a graphical tabular chart to list and analyze the potential cause of a given problem. Okay, so that means you have to identify what are the reasons. for the effect. So based on that we can identify. Okay, that is a cause and effect diagram. The cause and effect diagram is also called as a bespoke diagram because of appearance and appearance Ishikawa diagram after the man who developed in 1943. So this diagram is based on fishbone. Okay, it appears as fishbone. Okay, so this is a fishbone diagram. So here layout is a man and then method and then machines and then materials. These are the causes. If there is any problems occurred in manpower, if there is any problem occurring in method, if there is any problem occurring in machines, if there is any problem in the materials, so it leads the effect. So these are the some of the this is called the cause and effect diagram. So the effect will be based on the method, machines, materials, and man. Okay, right. So this cause and effect. Here we have one another example. Cause and effect. Here manpower and then materials and then methods and then machines. So in manpower we have insufficient information. So man can give some insufficient data. So material is nothing but some wrong source information, wrong purchase order, and then method no communications and the no procedure. There is no procedure means so there may be some problems, and also machines. Some of the problem corrupted data and then software problems from the machine side and then keyboard sticks. So these are some of the problems. These problems lead to the big effect. This in incorrect saving documents. So this is called as a one of the cause and effect diagram. Okay. So another one. Scatter diagram. The scatter diagram is nothing but it represents the relationship between two variables. So it is a graphical component of representation regression analysis. Okay, a scatter diagram is a composed of horizontal axis containing the measured value of one variable and vertical axis represent the measurement of the another variable. Okay, so here we have x and y variables. See, listen that here variable a and variable b. Based on that we can represent the relationship. How the variable is appeared based on the variable a and b. In order to construct a scatter diagram, so you need two variables to be plotted against the each other. One on the x-axis, another on the y-axis. So based on that we can represent the relationship between the two variables. There will be a lot of scatter diagram available based on the concepts. So this process is a continuous showing the effect of the changes in one variable against another variable, variable a and variable b. This will be represented as a scatter diagram. Okay, this represents the relationship between the two variable a and variable b. So another one we have strong positive relationship. So this represents the strong positive relationship between the variable a and variable b. Between the variable where we reach the maximum one line. Okay, so we can draw the straight line. This represents the strong positive relationship between the two variable. Okay, and then next one is strong negative relationship. This represents the strong negative relationship variable a and variable b. When variable a is here and then variable b is smallest value, so it represents the small to largest. So it represents the strong negative relationship between the variable a and variable b. Okay, so another one positive relationship. So both are equal. Variable a and b are positive, and it only in future it increase. So it's called a weak positive. Here this is variable a position and variable b position. So another one is this variable a b like that. So it's a increasing order. So it's represent the weak positive relationship between the two variables. Okay. So another one is a weak negative relationship. This is a weak negative relationship from starting from here to, and then at the end of the variable a is maximum and the b is minimum. So that's why it's a weak negative relationship. And then another one is represent the there is no relationship between the variable. So this will be appeared in anywhere. So variable a and variable b are there is no relationship between the variable. We cannot identify the relationship. We cannot identify the variable a and variable b relationships. There is no relationship will be represented in this diagram. Okay, so that's all about the types of the scatter diagram. Okay, another one control chart. So control chart represent control chart is nothing but a statistical process control. So that means each and every there is sometimes it varying, sometimes it increase, and sometimes it decrease. So based on that, it chart will be varying. Okay. So example, so it will be invented by Walter Shewhart. Is the most widely used tool in the statistical process control. The control chart is a graph that displays a data taken over time and variations of this data. There is a data will be taken based on time and variations. The control chart can be used to check whether the process is being controlled statistically. Okay. The histogram gives a static picture of process variability, whereas control chart illustrates the dynamic performance. That means it represents the dynamic performance of the variables. Okay. See the diagram. This is sample number, and then quality characteristics. Sometimes quality characteristics, sample 2 we have quality as high quality, high quality, and then sometimes in time moving automatically it decrease the quality, and then sometimes it increase. So we can these are based on that we can represent this is sample values. So average values you can take it, the upper control limit, lower control limit. Your products, that means quality, the quality means we know it's a excellence, that means minimum standard. Okay, so there is a here minimum upper limit will be this, and then lower limit will be this. Okay, so your quality will be should not be go less than lower limit, and should not be go more than upper limits. So this is concepts. So there are many timing data will be taken based on this control chart. Okay, so that's all. So thank you.